Hello guys, and welcome back to another episode of chemistry. And of course, today we're going to continue our study of carboxylic acids. Today we're looking specifically into the reactions. So this is chemistry. We're looking at reactions of carboxylic, the ones we call the alkanoic acids. Okay, the one called the alkanoic acid. Alright, do not forget that this tutorial is brought to you by the one and only O3SCHOOLS JAM CBT practice app. So please ensure you have that application on your phone if you want to succeed in your exam. Alright, so let us see a question from the app before we talk about the app in a moment. This is a 1997 question number 42. 1997 question number 42. It says, the reaction of an alkanol with an alkanoic acid in the presence of concentrated tetraoxosulfate acid will produce an A says an alkanal, B says an alkanoid, C says an alkanone, D says an alkyne. If you don't know one, you don't know one. All right. So please, that's why we're discussing reactions of carboxylic acids or alkanoic acids today. After this class, you will have full knowledge about the reactions that carboxylic acids undergo. So please do not forget to stay to the end of the class where we'll answer this question and many more questions from this wonderful application. All right, so please make sure you get the app. The app has all the past questions you need, so there's no need to go and get past question outside. As lecture notes structured according to the JAM syllabus, you must study according to your JAM syllabus. All right, so please ensure you get the app, and then also there's a question search feature. All right, the question search feature enables you to search for question according to topic, and the question that JAM has set under that topic will come out for you to answer. Another important feature that it has is the mock challenge. Okay, this mock challenge is the one that will conduct for all students that are writing JAM for this year. Every Saturday, you must participate in a mock exam with your mates. Okay, you get used to JAM past questions, JAM likely exam questions. Also, what's more is that you get used to what? You get to see your JAM scores released every Saturday. Your JAM mock score released every Saturday. So you're able to track your progress for the main exam. So please, activation for the app is just a little token. Okay, to download the app, go to Play Store and download it. All right, if you need activation details or how to activate the app, just send a message to this number on WhatsApp. This is 09121 515246. 09121515246. So let's go to the reactions of carboxylic acids. Okay, number one, I want to talk about what? Dissociation. All right, so we know that generally that acids are proton donors. Okay, so they donate what? Protons. That's why we call them proton donors. But carboxylic acids, they are weak acids. Okay, they are weak acids. So what they are going to do is that they partially dissociate into their ions. They partially dissociate into their ions. For example, if you have what? Ethanoic acid, CH3, COOH, okay, it will partially dissociate. Okay, so that's why I'm showing the reversible reaction. I'm going to have CH3 into CH3 COO minus. Okay, then plus what? Plus H positive. Okay, this one is what we call our carboxylate ion. Okay, why this one is what? It's called proton. Okay, so this is not the first time you have heard proton, because since when we have been discussing what organic chemistry, I'm talking about discussing chemistry from the very first topic. All right, so we have all the topics on chemistry on this channel. Okay, so make sure in case there's anything that has to do with JAM with chemistry or WAEC with chemistry, all the topics are on this channel, no capping. All right, so please, that is called a proton. Then this is called what? A carboxylate ion. So for example, just as we have seen what ethanoic acid being what partially dissociated into carboxylate ion and proton. We can also call this one what? Ethanoate ion. You can also call it ethanoate ion. All right, so take note of that. I can also say this is ethanoate ion. Okay, so that is that for that. So this is dissociation. So for example, if we have, let's say for example, benzoic acid. It's a benzene ring having what? Attached to itself a carboxylic acid group. Okay, this one can also dissociate. All right, dissociate into what now? We're going to have what? Ring. Okay, COO minus, then plus again what? H positive. Okay, what does this one be called? Okay, it's a carboxylate ion. So this one called what? Benzoate ion. Okay, this is called benzoate ion. All right. So please take note of that. So this is what dissociation. So carboxylic acids will partially dissociate into their what? Into their ions. Okay. So now let us look at another reaction that they undergo. All right. So it is important also to note again, like we have said earlier, that what carboxylic acid, they are acids. So then two na acid, then B. Okay. So they will react just the way that other acids like H2SO4, okay, or what ACl will react. Okay, so they will react the exact same way that what H2SO4 and ACl will react. The only difference is that because carboxylic acids are what? Weak acid, the reactions will not be as vigorous as these ones. All right, they will not be as vigorous as when H2SO4 or ACl will react. Okay, so that means what? Carboxylic acid, they can react with what? With metals. They can react with metals. Okay, when they react with metals, it will give us what? A salt plus what? Plus hydrogen gas. Okay, they can react with what? With bases. They react with base to give us a salt plus what? Plus water. Okay, they can also react with carbonates. With carbonates to give us what? A salt. All right, plus CO2 plus what? Plus H2O. Okay, so please take note of that. So they are acids, so they react the exact same way that what other acids will react. Just that because they are weak acid, the reaction will not be as vigorous as what? As those what other what acids that the ones we mentioned before. So let us say reaction with metals. So they can react with, for example, let's say we have what methanoic acid, that is HCOOH. Okay, they can react with a metal like sodium. All right. So if reacting with sodium, I'm going to have, all right, I'm going to have this. What I'm going to have, this will dissociate HCOO minus Na plus, then plus what? Plus hydrogen gas. It will give us what? Hydrogen gas. This is salt. Okay. So what will we call this salt? It will be called sodium methanoate. So we'll call this salt sodium methanoate. Okay, this is called sodium methanoate. All right, so it reacts a carboxylic acid like methanoic acid reacting with the sodium to give us what? Sodium what? Methanoate. It give us what? A salt, and hydrogen gas is what it's giving off. Okay, so they can also react. Okay, let's say let us check more reactions with this. Another metal, let's say methanoic acid also can react with calcium. All right, so if we react with calcium, I'm going to have what now? HCOO minus. Okay, then I'm going to have Ca. The charge on calcium is what? 2 plus. Okay, then plus what now? Plus what? Plus H2 still. All right, so you can either write it like this, showing the charges. These are two ways you can write it. Okay, you write the formula of the salt that is formed. You can either write it like this: COO minus Ca2 plus, showing the charges. Or you can write it like this: HCOO. If you don't want to show the charges, then you put what? 2, then you put Ca. So these are the two ways you can write the formula of this compound, this salt. Okay, if I'm showing the charges, you are going to be showing the charges on what? On the compounds, on the individual compounds, okay, or what or elements. Okay, so here I'm going to see what minus. Because what is negative, then here I'm going to see our 2 plus on the calcium. But if you do not want to put the charges, okay, what you simply do is to put what? HCOO, the 2 will be here, or Ca. So that means in case of this one, now this first one we did, where is it? So this one, Na is what? Is plus 1. Okay, so because of that, you can also write like HCOO Na. Okay, instead of putting those charges. So these are the two ways you can write the formula, okay, of the salt that is formed. So now that is what for calcium. Okay, you can also use what? Magnesium. Magnesium is the same thing. All right. So that is what an example. So with metals, they give us salt and what? And water. Okay, so the salt and water and hydrogen gas. Okay, that's the product, salt and hydrogen gas. So now let us check with bases. Let us check with bases. An example. So let's say for example we have carboxylic acid like this, C2-propanoate. Okay, that's a propanoic acid rather. Propanoic acid, C2H5COOH. Or you can write it as CH3CH2COOH. Okay, any way you want to write it. So they can react with a base. Okay, like for example, let's use a base like KOH. KOH, okay? That's potassium hydroxide. So what I'm going to have, dissociation will also what happened here. So here, we're going to have what our C2H5COO minus first. They are going to have our K. Our K, is it plus 1 or plus 2? Is plus 1. So plus K plus, okay? Then what will be giving off? I'm going to have a salt, because this is a base, this is an acid, this is an acid. Okay, then this is a base. So I'm going to have a salt plus what? Plus water as product, plus H2O. Okay, so it's as simple as ABC. Okay, so that is what one example. Let us see another example. Let's say we use butanoate. Okay, sorry, butanoic acid. I'm always saying butanoic acid. Okay, let's say we have C3H7COOH. Okay, plus let's say this time we use calcium oxide. Okay, use an alkali like calcium oxide. So what I'm going to do, get of course the same thing, C3H7COO minus, they are going to have our Ca. Our Ca is what? Is 2 plus. The charge of calcium is 2 plus. Ca 2 plus. Then plus what now? Our H2O. Okay. So what can we do? What to do? Or we can also rewrite this one as well. C3H7COO. Okay. To Ca. Okay. So what is this one we call? This one, what will we call this one? We call this one potassium. Potassium what now? Propanoate. Okay, because of potassium what? Propanoate. Okay, or potassium propanoate here. Then of course, what I'm going to call this? This potassium propanoate, correct? Then what I'm going to call this one? I'm going to call this one calcium what now? Calcium what? This is what? How many carbon? How many carbon atoms are here? C3 plus this one, that is C4. So this is called calcium what? Butanoate. Okay, so we'll call this one calcium butanoate that is formed here. Okay, so this is what carboxylic acid reacting with what? With the base to give us a salt and what? And water as what? As product. Very important. So now we metamorphose. Okay, let us see reaction with what? For example, a carbonate. Let's see reaction with carbonate. So they can also react with what? With carbonates. Can also react with carbonate to give us what? Water and what? Carbon dioxide as what? As product. All right, so with carbonates. So let's say we have what? Methanoic acid, HCOOH, reacting with calcium carbonate. Okay, so simple, same thing, the same approach. Okay, but this time you know that we're having what? Water, having carbon dioxide as what? As a salt, as what? As product. Okay, so now I'm going to have what now? This will give us what now? You dissociate this HCOO minus. Okay, then I'm going to have what? Ca2 plus. First of all, this dissociate minus Ca2 plus, then of course plus CO2. Then plus what? H2O. All right, so you can also write this as what? As CaCOO, okay, to Ca. But what I want to call this one? So we call calcium methanoate. This is called calcium methanoate. Of course, this is carbon dioxide, and this is what? Water. All right, so we can have more examples, but this is what enough. So just what with the big fact to show you that what that carboxylic acids can also react just like what other acids. They can react with what? With metals to give off hydrogen gas. They can react with bases to give us salt and water. They can give us with what? With carbonates to give us what? A salt, carbon dioxide, and what? And water as product. Okay, so now let us continue. Let's see the last reaction. We should have talked about 2 more, but I think I will introduce acyl chlorides. Okay, there's another family, acyl chlorides. There's another family of organic compounds I don't think we really talked about. Okay, these are what acyl chlorides. This is a functional group. Arrow C double bonded to OCl. Okay, so this is what? Another what? Group of family. Okay, acyl. Maybe we'll talk about them anyway because this is acyl chlorides. We want to talk about this last reaction. Let's talk about the reaction first. So this reaction is esterification reaction. Esterification reaction. Okay, it's a reaction between what? An alkanol. Okay, plus what? An alkanoic acid or a carboxylic acid to give us what? An ester plus what? Water as what? As product. Okay, in the presence of what? Of concentrated tetraoxovesis acid. Okay, so in the presence of concentrated tetraoxovesis acid, all right, an alkanol can react with an alkanoic acid to give us ester plus water as product. Now, sorry, we're talking about the acyl chlorides now. This reaction is kind of what? Vigorous. Okay, so if you want a mild reaction, what you do is that you produce this ester from an acyl chloride, all right, from an acyl chloride. Why we talk about acyl chloride? Acyl chloride is very important because, first of all, alkanoic acids, okay, they do not react. Okay, they do not react basically with what? With aromatic compounds. Okay, they do not react with aromatic compounds. Okay, but what? An acyl chloride can react with what? With an aromatic compound. All right, so that is why most time we talk about acyl chloride. Maybe we'll chip them in as we continue, but that's the functional group. Arrow C, double to O, then Cl. Okay, so this is called what? These are the acyl chlorides. Okay, so let us continue. So now this is what? Esterification, an alkanol plus alkanoic acid to give what? Ester plus water. So an alkanoic acid like CH3COOH, then plus what? An alkanol like C2H5OH. This is what? Ethanol. This is what? Ethanoic acid. Okay, this is what? Ethanol. Okay, what it gives us is what? It's an ester. Okay, so I'm going to have what now? H3 COO C2 H5 plus what? Plus H2O. This is what? An ester. Okay, this is what? Water. All right, so this is what the product of what the reaction it gives us what? An ester and what? And water as product. Okay, so please take note of what of that. This is called esterification reaction. When we get to esters, we talk about esters more. All right, let's just leave the nitty-gritties. Okay, but this is another reaction of what? Of alkanoic acids. Okay, so they react with alkanols, all right, in the presence of concentrated tetraoxovesis acid. All right, this will be here. Okay, then to give us what now? An ester and water. All right, so this is called ethanoids. Okay, this is called ethanoids. When we get to esters, we'll talk about to name esters. All right, it's very, very common. This question can come out 1 million times in your exam, so you can always see it again. Okay, if I say Master T, predict one question for next year jam, I can put this one in organic chemistry. Okay, it has come out repeatedly. I don't know, maybe examiners like the name esterification. Maybe in the sweet them. All right, so please make sure you commit this word to heart. We will see it again when we get to what? Esters. All right, so but for now, make sure you like this video. Make sure you subscribe to the channel. Let us go to the app. Let us see the question, and we'll be done with this class. This is a 1997 question, number 42. Number 42, it says, the reaction of an alkanol with an alkanoic acid in the presence of concentrated tetraoxovesis acid will produce an A, they say an alkanyl, B says an alkanoid, C says an alkanone, D says an alkyne. All right, somebody will say the answer is not there. That's what that is supposed to be ester. Okay, these esters that also called what now? The alkanoids. Okay, they also called alkanoids. Okay, so when we get to esters proper, but I will see that and we'll know that. Okay, but just note for now that what esters are what called what? Alkanoids. Okay, they're called alkanoids. All right, so please, that is that for now. So just like what you have said was here, I'll say what? An alkanoic acid. Some of you know that carboxylic acid also called alkanoic acids. Okay, well, these ones are called what? Alkanols. Okay, this one are called alkanoids. All right, please take note of that for record purposes. All right, so my name is Master T. All right, in the next class, we'll talk about the test and uses for what? For carboxylic acid. All right, and we're done with carboxylic acid. Thank you for watching. I will see you there.